Welcome to Spring LIB.
Hi everybody, thanks for joining us today. So what we're going to be looking at is a relative velocity problem, and what we're given is this rod AB that is moving to the right at 25 inches per second applied at point A, and it is moving about this point C where there's just a wheel. What we're asked to find is the angular velocity of this rod AB and the velocity at point B. So first thing that we've done is we've defined our coordinate system. We have I hat moving to the right, J hat moving in the vertical, and K hat moving out of the page toward us. And keep in mind that this coordinate system is centered at point A. Next thing we're going to do is we're going to solve for angle theta, which is defined as this angle here between the rod and the ground. And we'll see why this is a lot useful for us later on. But we can solve for theta using the inverse tangent relation, using the dimensions that we have known, obviously opposite over adjacent. So inverse tangent of 7 over 10 is equal to 35 degrees. Next, what we're going to do is we're going to explore this velocity concept with the relative velocity relation. So we know that the absolute velocity at C is equal to the absolute velocity of A plus the velocity of C relative to A. We can also write this as equal to the absolute velocity of A plus the angular velocity of C relative to A crossed with the vector from C to A. Now looking at what we know and what we don't know, we know VA, which is given to us right here as 25 inches per second in I hat. We can go ahead and write that in. 25 I hat. We also know RC given A, and that basically means from A, how do I get to C? So we can see that's 10 in the I hat direction and 7 in the J hat direction. So we can write this as plus omega C given A crossed with 10 I hat 0 plus 7 J hat. And this is equal to VC. Moving on, one of the things that I want to say is that we can write VC and break it up into its components as well. As we look closer at the drawing, we can see that if I'm just going to draw VC here on the side, that's VC. The angle that VC has relative to the ground, that angle, is also theta. So we can invoke that and break up VC the vector into its components and say VC cosine theta I hat plus VC sine theta, let's see now, J hat equals 25 I hat plus, now omega CA is actually just omega rod because we're dealing with a rigid body, and the angular velocity of the entire rod is going to be the same as the angular velocity between the points C and A. So we can go ahead and write that as well as omega rod. I'm just going to write that as W. Here. Go ahead and write that as omega, write that as K hat crossed with 10 I hat plus 7 J hat. Now, you might be able to see this already, but there are actually two equations within this because of the I hat and J hat designators. We'll see that the K and the I and the K and the J's cross with each other actually yield I and J's as well. So if I make the equation first for the I hat equation, so we see that for the I hats, VC cosine theta, next term is a J hat here, is equal to 25. And what we see here is that K cross J is actually negative I. So we'll actually add that in here. And that's minus 7 omega. That's our first equation. We can use our next equation now for the J hat. And we'll see that VC sine theta is equal to, now K cross I, right? K cross I is actually J hat. And that's, we can write that as 10 omega. So right now, you can see that we have two equations that we can solve for, two equations with two unknowns, and we can solve for omega and VC. Now we're really only interested in VC. So once we plug in for theta, we get an omega rod of 1.17 radians per second. So that completes one part of our objective. Remember, we're not done. We still have to solve for VB. Now, VB can actually also be solved using a similar technique that we use here. And instead of C's, we're just going to plug in and put B's. I'm just going to write that out for being complete. And we can use that same argument, and say that VB is equal to velocity at A plus the velocity of B relative to A. Now this is also the same as saying the velocity at A plus omega rod, remember it's a rigid body, cross RB given A. Now same thing, what do we know, what do we not know? Obviously we don't know VB, so that's going to be VB equals, we know VA, which is 25 I hat. We know omega rod, which is 1.17 K hat. Now what is RB given A? So let's scroll back up, and we can see here that the entire length of the rod is 20. And we can do the same thing as we did for the VC and break that vector up into its components using that same angle. So what we can do is we can say 20 cosine theta I hat plus 20 sine theta j hat. And that is our equation for, a little nicer. And that is our equation for VB. So if you look at it, the only thing that is actually unknown in here is theta, but we know that's 35 degrees. So plugging in for theta gives us a VB of 11.6 I hat plus 19.17 j hat. And that is our final answer. Thank you.